Hi, welcome to Chapter 3, Section 4. I'm Mrs. Kim and I'm here with Mr. Erling and Mr. Knox. In this section, we're going to be learning about the cell in its environment. It begins on page 102 and goes up to 107. The essential question we would like you to learn in this section is, what is the difference between diffusion, osmosis, passive transport, and active transport? By the way, this is part 1 of section 4 video. There is a part 2 after this one. What controls things that go in and out of the cell? It's the cell membrane. And we say that it's selectively permeable. It selects what goes in and out because they don't just allow anything to go in and out of the cell. Only some materials can enter or leave the cell, and that is decided on by the cell membrane.
So there's a few ways that things can get in and out of the cell. The first way is diffusion. And diffusion is the movement of stuff from a high concentration to a low concentration. If you think about a fart, or if you think about a cologne, it's very concentrated in a small area, but as time goes on, that smell diffuses throughout the classroom. So diffusion is stuff, small molecules moving from a high concentration to a low concentration. Now, osmosis, because water is so darn important for life, they give it a special name. Osmosis is just the diffusion of water through a cell membrane. That's all it is. It's water going from where it's very wet to where it's drier. So osmosis and diffusion are very, very similar. All right, please pause the video and describe the difference between osmosis and diffusion. All right, you should have paused the video and described the difference between osmosis and diffusion, and we will move on. Make sure you guys do know that. So, osmosis in your body. Your body is trying constantly fighting to maintain homeostasis. Remember, homeostasis is your body trying to stay the same. So in your plasma, you don't want too little water. If you guys have too little water, the water will leak out of your red blood cells and go into the plasma, and your red blood cells will shrink. On this case, if you have too much water, the water will enter your red blood cells, and your red blood cells will start to swell up, and that's not a good thing. So you want just the right amount of water in your plasma so your red blood cells work properly. So osmosis in your red blood cells is the water moving in and out of your red blood cells.
Alright, so why can't people drink large amounts of salt water? Hopefully you already know you can't drink lots of salt water. Maybe you went to the beach, you accidentally swallowed some, didn't make you feel too good. Well, if you drank a lot of it, here's what would happen. The salt water causes water to move out of the body cells. This makes your body cells become shriveled, and over time this would lead to cell death and eventually the death of the organism itself. Passive transport is when materials pass through the cell membrane without requiring the cell's energy. So think about it like riding a bike. We all know going downhill doesn't take much energy at all. You don't need to pedal. Maybe you might need the brakes instead. Diffusion and osmosis are both passive transport. If we look in the picture over here, we can see the cell membrane, and we notice there's a lot more particles on one side of the cell membrane than the other. So a particle in an area of high concentration, meaning there's a lot of these particles, diffuses through a protein in the cell membrane to the other side where there's not as many of these particles.
Okay.